Hey, what's up? This is Václav. This is a follow-up on the earlier EV charging automation video. It was sort of working, but I had a couple of issues with it. First, it was not really controlling the charger, but it was trying to understand which car is being charged and then talking to the individual cars through an API. It was not clean, and there were a couple of issues with that. More on that later. Also, the charging power range is very limited, so I always considered it as a temporary situation. I was just waiting for the right wallbox to do it properly. But it was not coming, so I hacked it. But before I tell you how, let me explain the issue first. My goal is to charge the 2 electric cars from the solar panels on our house. This doesn't seem like a very ambitious objective, but it's in fact surprisingly complicated. So far, I was using the Wallbox charger supplied with the car. The charger doesn't have any controls, so I use the car API to control the charging current. To do that, I had to make sure I talk to the correct car being charged. So first, making sure that the car is at home, and then that it's charging. And based on that, I chose the correct API and parameters. The other issue is that the API is unofficial and it often stops working. Škoda considered the Home Assistant integration as a breach of their terms and conditions. They're afraid that it might overload their servers by too many requests and impact their availability. So the amount of API calls, both from the mobile app and the Home Assistant, is therefore limited. And after I consume this amount, it just stops responding until the car is physically started, and sometimes even longer. Also, both cars are from the same brand, but each uses a different version of API. The newer API that is used in the ENIAC is, in my opinion, worse. It actually doesn't allow controlling the charging current. I can only set it to high and low. I suppose they want to keep it simple, and their goal is to make sure the EV charging does not overload the circuit breakers. They really do not target managing the charging power to match solar panels, I suppose. And if all of this is solved, there is the general issue of power ranges in which I can control it. This is general, it doesn't really relate to the Wallbox. The charger can be used in one-phase plug, and then it can charge from 1.4 kilowatts to 2.4 kilowatts. Or a 3-phase plug, but then it can control it only between 4.5 kilowatts to 7.5 kilowatts. So if I use the 3-phase plug and I would like to use it to charge it from the sun, taking into the account the house consumption, I won't be charging until the PV gives more than 5 or 6 kilowatts, which would limit that to a relatively short period and only during sunny days. So I was mostly using the one-phase configuration. But controlling it between 1.4 and 2.4 kilowatts, it's quite limited. And sometimes I didn't manage to charge both cars during the weekend. So I was looking for a Wallbox that could allow controlling that in the full range. Turns out it's not very common. And the one that promised control the full range turned out to be a slight marketing trick. At the end, I achieved that, but through a quite brutal hack. But before I explain, let me explain how the charging works. The car charging supports 2 modes, DC and AC. The car battery is obviously DC and the grid is AC, so in both cases, there has to be a rectifier that converts the AC to DC. The difference is that the AC charging uses a rectifier built into the car, and the DC charging uses a high power rectifiers that are in the fast chargers. As of today, the power of these DC chargers range from 50 to 350 kilowatts. So they are really designed for commercial use. They're somewhere between 125 and 600 amperes per phase. They have active cooling, so not really something you'd use at home. So all the wallboxes you buy for your home, as well as the chargers on the streets, are level 2 chargers that use AC. Which is pity, because the solar panels generate DC, So to charge the car, I first use the inverter to convert the DC to AC, then send it through the wallbox to the car that converts it back to DC. And both the inverter and the rectifier have losses, so if I could use the DC directly, it would be the best. But I don't know about any DC wallbox out there. They would probably be part of a proprietary solution coupled with the inverter, and as far as I know, GoodWe doesn't have such a thing. So we'll be talking about the AC chargers. If you see a 22 kilowatt charger on a street, this is an AC charger. Unlike the fast chargers, they do not have charging cables, but plug, and you have to use your own cable that you have in a car. They deliver a maximum power of 22 kilowatts, but the actual power actually depends on the maximum power of the rectifier in your car. Most cars today, including Tesla Model 3 and my car, have only 11 kilowatt rectifier. As far as I know, the 22 kilowatt rectifier is only in Renault Zoe, BMW i3, Tesla Model S, and Tesla Model X. Anyway, so at home, I'm limited to 11 kilowatts, which is perfectly fine for me. Unless I plan to go for a long trip, the car battery management normally charges to 80%, and the battery usually does not go below 20%, so if I have an 80 kilowatt hours battery, I need to charge maximum 50 kilowatt hours, usually less, which would take a bit less than 5 hours on 11 kilowatts, which is perfectly doable overnight. And if I need to recharge faster, I would use one of the fast chargers in the area that would charge it in 30 minutes or so. But in the 3 years we have the cars, we have really never needed that. So 11 kilowatts is just fine. I would not want a faster charger at home. It uses 16 amperes per phase maximum, and my house has connected with the 25 amperes circuit breakers, so it works fine with our existing connection to the grid. If I wanted a faster charger, 22 kilowatts, if my car supported that, I'd needed to upgrade the circuit breakers, and it would increase our monthly bill fixed fees, which is now a bigger part of what we pay, since most of the consumption is covered from the solar panels. The fixed fees there are fixed. Also, I want to use the solar panels for charging the cars, and the inverter is 10 kilowatts as well, so 11 kilowatts wallbox is perfect. In fact, it's too much most of the time, because other panels give 10 kilowatts only in peak, and they are divided in half between southeast and southwest direction, so most of the day it's actually less. I actually do not know if they ever output the full combined power due to the split in the two directions. So if I want to charge the car from sun, I need to decrease the charging power to match the solar output minus the house consumption. So now we've established that the wallbox maximum power is limited to 11 kilowatts, which is 16 amperes times 240 volts times 3 phases. At least this is what we have in Europe. On the bottom end, it's limited by the minimum charging current, which is 6 amperes. This doesn't really depend on the wallbox or the car. This is a standard. So if the current goes below 6 amperes, the cars will just stop charging, which explains the limit that I explained earlier. On 3 phases, 6 amperes times 240 volts times 3 phases is 4.3 kilowatts, so 4.3. This is the minimum you can charge with a 3-phase charger. If I use a 1-phase charger, then it's 240 times 6 is 1.4 kilowatts. I can't charge less than that. In fact, I probably wouldn't want to charge less than that anyway, because the efficiency actually decreases with the decreasing power. So to minimize losses, you actually want to charge on one of the higher settings. So the maximum on the 1-phase is capped to 3.8 kilowatts, which is 16 amperes times 240 volts. So if you would want to control the wallbox in the full range, it will have to be able to dynamically change between 1-phase and 3-phase charging. I was in discussion with Škoda. They claimed that they were working on something like that, but I don't know if it will ever materialize. I was also in contact with another wallbox manufacturer, but the discussion didn't really result in anything tangible as well. At the end, I gave up and I bought a wallbox that claimed that they can control it in the range from 1.4 to 200 or to 22 kilowatts. But I kind of knew it won't be that simple. And it wasn't. So it allows controlling the current between 6 to 16 or 32 amperes per phase. And that's it. But there is no way to control the total current across all phases or the number of phases it uses. I wrote to them that the information on the web was misleading, but they told me that they were comfortable with it. They can control it down from 1.4 if I connect it with one phase, and up to 22 kilowatts if I connect it with 3 phases, and I can choose between the two at the time of installation. So they're fine. And there is a dip switch where you can limit the maximum current to 32 amperes or 16 amperes or other values. Anyway, so I asked them what would happen if I disconnected or connected the phases using a smart switch. And they told me that I should not disconnect phases during the charging. But what I can do is I can turn the wallbox off, disconnect the circuit breaker, and then connect 1 or 2 or 3 phases. And then when I start it, it will work with the amount of phases connected. And I was thinking that I could perhaps try just to stop charging and then disconnect or connect the 2 remaining phases and start charging again without disconnecting circuit breaker. But I didn't really try that. I don't want to break it, and I doubt it would work anyhow. I assume it figures the operational mode when it boots. I might be wrong. If some of you have some more details on this, let me know. But for now, when I want to change the number of phases, what I do is I turn off the charging, then I turn off all the phases, and then I wait, and then I turn on the number of phases I want, and it works. I might be able to switch it faster, but I'm playing it safe. And then there is one more thing. The inverter I have is asymmetric, so theoretically it could send all the PV output to one phase. But there is a limit, it's not working 100%. I figured that if I load 16 amperes on one phase, even if there is enough PV output, it will still import some energy from the grid and export the other 2 phases at the same time. What I try to do is I try to limit it to 10 amperes, which I figured works without import. So I do not only switch from 1 phase to 3 phases directly, but I use 2 phases in the middle. The Wallbox apparently supports that. So there is an overlap. I can get 3.8 kilowatts with 16 amperes in one phase, or 8 amperes in 2 phases, right? So what I actually try to go to 10 amperes and then switch to using more phases, except if I want to charge on a full power, and then there I just switch all 3 phases on 16 amperes. And one more thing, when it's a cloudy day, the PV power output can change quite often, but I don't want to switch off and on the wallbox all the time. So whilst the automation adjusts the power every minute or so, when I switch on the wallbox, I start a timer that will prevent switching it off again for the next 15 minutes. So sometimes I can actually see that the solar output dipped below the minimum charge power, or that I could achieve more with turning on more phases. But then the house battery would cover the delta, or it gets an extra charge for a couple of minutes. And when the timer expires, it will adjust the number of phases, so that it would only be temporary. Anyway, so let me show you the setup. I connected the Wallbox to a dedicated 3-phase 16 ampere circuit breaker. I'm using a 6 millimeters cable. That's by the norm. because the wallbox consumes the power all the time. So they use this general diameter to make sure it doesn't overheat. Said that, 6 millimeters, it's really thick. It will be okay for 22 kilowatts with a reserve. For 11 kilowatts, 4 millimeters would be fine. But anyway, it's not connected to the wallbox directly. There is a Chalet 3 Pro, which is a 3-phase small switch, and that only supports 16 amperes per phase. So it will only support 11 kilowatts, but it's connected to a 16 amperes circuit breaker anyway, and I configured the wallbox to limit the current to 16 amperes, so we're fine. So I can now power the wallbox by 1 phase, 2 phases, or 3 phases. All the configurations are supported by the wallbox. Next, I need to be able to set the charging current, and I have 2 ways to do that. The wallbox supports OCPP protocol, and there is an OCPP integration for Home Assistant, so that I can use that. OCPP is a standard protocol for communication between charging stations and central charging station management. You can manage quite a large network of charging station with that. Or the wallbox I have actually has a simple Home Assistant integration, which is proprietary, and I can manage the wallbox directly through that. I kind of prefer the OCPP, but after some testing, I decided to use the wallbox integration. It just works, and I had some issues with the OCPP. I might come back to this, but regardless, this doesn't really matter. The only thing I do with it is I'd like to see whether the car is connected, and I'd like to start or stop charging and set the current. The configured current is per phase. So if I set the current to 10 amperes, for example, for 1 phase, it'll give 2.4 kilowatts, for 2 phases, 4.8 kilowatts, and for 3 phases, 7.2 kilowatts. So the charging power is a combination of the number of phases and the current. So all I need to do now is I need to make a script that takes the desired charging power as an input and figures out the best combination of the number of phases and the charging current. So here is the script. Let me explain. So this is the script. If I would just open the script information, it uses one parameter or one field, which is the amount of watts. So if I would just run the script right now with this parameter set to 5760, it will set the wallbox and the amount of phases to deliver 5.7 kilowatts. So this is how the script is used, and it's obviously used from the automations, but I could also run it like that from the user interface. Now, before I dive and show you how the script looks like, first, the script uses one helper, which is the amount of phases. So currently it's set to 2 phases. Let me actually show you what it is. If I would go to devices and I would go to Wallbox, there is the Chalet switch, and it has those 3 phases, and currently, as you can see, 2 of them are on and the phase 3 is off. And so this is what this helper is doing. It actually calculates, it iterates through those 3 switches. So there is this switch 1, switch 2, and switch 3. So there is a list of those 3 phases, and it'll iterate through this list. And each time it actually finds a switch which is in state on, it will increase the amount of phases that are on. So initially it's set to 0, and each time it finds a switch that is on, it will increase the number. So at the end, it will return the amount of switches that are on. So currently it's 2. I use the unit of measurement hertz, which is not correct, but actually there is no unit of measurement that would say the amount or pieces, number of pieces. If you have like an ERP or any business systems, you would have some like each or pieces, but Home Assistant doesn't have it. It's not ERP apparently, so I'm using frequency, but at least I could see it in the statistics. But this is what it is. So currently 2 switches are on. So this is the helper. And the other thing I'm using, in fact, is if I go to the devices again, there is this Wallbox integration, and it's using a number of those entities in here. So there is the status, and there is this switch, pause, resume, where I can turn it on and off. Currently the cable is not plugged in because it's in status ready. If it was plugged in, it was in different status, so I can't actually turn the switch on. But most importantly, there is this maximum charging power. It's now zoomed in, so I don't see it whole, but if I click on it, it's called Wallbox maximum charging current. The entity ID is a number, Wallbox maximum charging current. It's currently set at 7 amperes, and this is what is used in the automation. Together with this switch, so this is switch, Wallbox, pause, resume, and I think I also use this status to check whether the cable is plugged in or whether it's charging or not. Back to the automation. So first, here we have the field. The field, actually, it's a number, and the number is in a range from 0 to 11 kilowatts in the 10 watts increments. So this is what we have. It's called new value. And before I go to the script, there are 2 conditions I'm using before I actually start the script. In fact, 1 condition. The second one is already turning off the Wallbox. But let me show you what this condition is doing. So this condition is making sure that the Wallbox is on, because if it's off, then in the script I'm using the entities from the integration, and if it's off, they'll be unavailable, so I won't be able to see anything. I won't be able to see if the cable is plugged in and whether it's charging. It will be just unavailable. So the first thing I'm doing is I'm making sure that the number of phases is not 0, so it's 1, 2, or 3. So it's saying in Wallbox phases, this is the helper I had. If the state is 0, what I'm doing here is I am calling the service switch turn on, and I'm turning on at least one of the phases, and then I'm waiting 10 seconds. So this is kind of housekeeping first action. This came out of experience. I didn't have it there initially, and sometimes the script was failing if by some accident the Shelly was, all 3 phases were disconnected. This is what it would do, usually after power outage or something. So this is the first one. Then the second action is if the power is less than the minimum power. So we spoke about the 6 amperes times 1 phase. So if it's less than that, then if the Wallbox is on, so if the switch Wallbox pause resume, so this is this switch, if it's on, then I'm gonna call the service turn it off. And the reason I'm checking the state first is I don't want to keep calling the service turn it off, turn it off, turn it off each time when I call the service if it's already off, especially when it's talking to the Wallbox over the cloud. I don't want to do that, so I have this this in here to prevent those service calls. How do I actually determine that this is less than the minimal power? I make it a little bit complicated actually. I differentiate between when the Wallbox is charging and when it's not. Because when it's charging, I don't want to turn it off unless the new power is really less than 1400. But when it's not charging, I don't want to necessarily turn it on before the power is a little bit higher, and I set it here to 1600, so not a big difference, 200 watts, but I build this type of hysteresis in here. So now we manage the situation how to turn off the charging, and now for the rest. So here I'm defining a couple of variables to determine the number of phases. So first I need to work with the current number of phases, which is simply the state of this sensor Wallbox helper we were seeing before. I'm using it in multiple places, so I'm just creating variable out of it. And then I calculate the amount of new phases. as you can see, the template is slightly complicated. It could have been as simple as if the new value is bigger than 4000, then it's 3, else if the new value is bigger than 2400, then it's 2, else it's 1. But there is, I built in a hysteresis in it, and there is also this timer. So what I'm saying is, if the timer that is saying that I have changed the phases is idle, then I will consider changing the amount of phases. If it's not idle, then I will say the new number of phases is the same as the current number of phases. So I'm not switching anything. So this is the timer. And then the hysteresis, what I do is I have a different value for turning the phases up and turning them down, if you will. So what I'm saying is, if the current number of phases is 3, then I only need more than 4000 to keep it on 3. But if it's 1 or 2, then I actually wait a little longer. I wait for the value to be more than 5 kilowatts to switch it from 2 phases to 3 phases. And the same thing with 2 phases. Again, if I have 2 phases already, then 2400 is enough for me. But if I have 1 phase, then I wait 100 watts more. So I want a little bit filter out the switching on the borderlines. There is a bit of hysteresis. So this is the variables I define, and then I'm using those variables in here. If the new value is different from the current value, then I will turn off the charging if it's on. So if the wallbox is currently charging, if it's in the state on, then I'm going to stop the charging. Then I set the new charging current. So I set the value wallbox maximum charging current. So this is the maximum charging current from the wallbox integration. I'm setting it to a this new value divided by 240 volts divided by the new number of phases. And I'm capping it to 6 amperes at the bottom and 16 amperes on the top. So this is the charging current. Then I'm waiting about 5 seconds, and then what I do is I turn off the whole wall box, and then I wait 5 more seconds, and then I turn on the desired number of phases. So if the new phases is 3, then I'm going to switch all 3 phases. If it's 2, then I'm going to turn on phase 1 and 2 only. And other than that, by default, I just turn on phase 1. And then I start the timer. So this is going to block changing the phases for the next 15 minutes. So there's 15 minutes timer that I'm starting right now. And then I'm waiting 15 seconds when I turn on the wall box. So remember, all of this is happening just in case that the amount of new phases is different from the current phases. So if this happens, then I'm switching between 1, 2, and 3 phases, starting the timer, and then I'm waiting 15 seconds. Then I'm setting the max current again. Now, I've done it here before I turned off the wall box. So I'm kind of doing it twice. But the reason I did it here in the switch is because I wanted to make sure when the switch or where the wall box is turned on, it's already turned on with the limit, because when it's on, it already starts charging the car. So I wanted to set it first. But I want to set it here as well, because if I was not switching the phases, in this case, I want to switch just the current without switching the phases. So here I'm calculating the maximum current based on the number of phases that I have, and then if the current is different than the one I have calculated, that I'm actually calling the action number set value, and I'm using the charging current. So this is setting the charging current, and then if the charging is currently off, then I'm just turning on the charging, just making sure that the charge is on. So that's the script. I have one more action that is triggering an automation that configures the inverter to a backup mode. So the house battery is not being used when there is a severe weather warning, or when I'm charging the car in the fast charging mode. Because in case of the severe weather warning, I want to make sure that the battery is fully charged. But in this case, when I'm charging the car on a fast charging mode, the house battery wouldn't make much difference. I would just cycle it for no reason. The house battery is 10, or I have upgraded it to 14 kilowatt hours. And the two cars, they have 80 and 40, so 120 kilowatt hours in total. So the 10 kilowatt hours battery, it would not make any difference to charge the cars. I would just cycle it for no reason. So I'm just switching it to a backup mode. So this is what it does. I'm just triggering the automation in here. This is optional step. So this is the automation. Let me show it to you in the YAML. So there is the field. There is the first sequence, making sure that the wallbox phases is, if it's 0, then I'm gonna turn on phase 1. Then there is the small power that I am actually, when it's less than 1600 or 1400, then I'm going to turn off the wallbox, and then I'm gonna stop the script here. And then I'm defining those variables, so you saw the YAML there. And then if the amount of phases is different, then I'm just stopping the charging, then setting the charging current, then waiting 5 seconds, switching off all the phases, waiting 5 seconds, and then I have the choice between 3 phases, 2 phases, and 1 phase, and I'm just turning those on. And then I'm calculating the current again. This is happening regardless whether I change the amount of phases or not. So I am calculating the max current. If the current is different, the new current is different than the current one, then I'm setting the value. And if the wallbox is turned off, then I am turning it on. And actually, one thing I forgot, I have a timer here that is for when I changed the phases. I also have a timer that I start when the EV charging was triggered, so I know when the EV charging was turned on in case it was off before. And then at the end, I'm triggering the automation. So this is the script. I'm sure that many of you will ask me to share it, so I will. It's in the description. But bear in mind that if you want just to take it and use it, this is not that kind of video. You'd have to understand what it does and tweak it to meet your specific configuration. Anyway, if you make your own version and it's better than mine, let me know in the comments. I might like to steal it from you. Okay, so that's the script. It's called Binary Automation that runs once per minute, and it's based on the charging mode. It figures out the best charging power. I made the video about it earlier, and I didn't really change the automation since then. I only changed the script to control the wallbox. The automation has 4 charging modes. Fast, that configures the wallbox for a maximum power. Then off, that turns it off. And I could use that to turn the charging off even though the charging cable is connected, and then start it manually, for example. Then the one we have discussed today, the solar mode, that calculates the charging power based on the solar production and host consumption. And that one is kind of over-engineered. It also takes into the account the state of the charge of the house battery and the forecasted remaining solar production until the end of the day. I don't want to end up with a charged car but empty house battery, so I'd run the house from the grid the whole night. That one is kind of patched together. I'm not proud of it. It works during the summer, but I will probably get back that one before the autumn if I get these solar forecasts working more reliably. And then I have one more mode that I use mainly in the winter, that charges the car from solar during the day. But if it doesn't charge to a set minimal amount during the night, it will charge that to that minimum amount from the grid. And all of these, they just call the script to set the desired charging power. And if I call it with 0 or less than the minimum charging current, it will stop the charging. So another over-engineered automation. Does it work? Well, I'm not saying that this is something for general masses, but for me, it actually works quite perfectly, and I like that. From March till October, both of our cars basically run on solar power, except when we go by car for a really long trip and we charge it on the way, somewhere further than 300 kilometers away, which happens about 3 times per year. Typically we charge both cars during the weekend, but if we are out on Sunday or if it rains, we still manage. If I leave it plugged overnight, in the morning it usually adds about 10% before we leave the house, which is okay for the day. Besides, I often work from home once or twice per week anyway, and if I come earlier from the office and plug it in, it is still charging till 7 p.m. Or so during the summer. And I really need to charge the cars about once or twice per week, so we have plenty of flexibility. Anyway, this is it, and I see you in the next one. Bye.